Hello, and thanks for joining this lightning talk, where we're going to talk about how to leverage automation within your CI/CD workflow to enhance infrastructure security requirements. So why do we want to automate infrastructure security guardrails? While adopting cloud-native architectures, we treat infrastructure more like software, where it's provisioned, tested, and managed through declarative languages. The ephemeral nature of cloud infrastructure makes it hard to quickly identify and remediate security issues when you're limited to scanning only at runtime. So we want to make sure that we evaluate the code used to manage our infrastructure components as early as possible and using automated workflows and tools so that our security approach can scale as our environment scales and evolves. And doing these security checks in your pipelines before changes are made into your runtime environment is ideal, as it's easier to check for issues and fix them with minimal impact. And today we'll demonstrate how to do this. Let me introduce myself before we get started. My name is Cesar Rodriguez, and I'm a developer advocate at Accurix. I've been working as a cloud security architect for most of my career, implementing cloud security programs and helping organizations with their cloud migration. And I enjoy contributing to open source projects. So one of the most scalable approaches to implement your security guardrails is using policy as code. So policy as code means that you're writing the security requirements that are important for your system to be compliant with as code into a declarative language that can be used to evaluate your infrastructure as code against. So your Helm charts, your Kubernetes configuration, YAML, Terraform, or any other declarative language can be evaluated using policy as code. And this makes sure that you're consistently enforcing your requirements as part of your system's development lifecycle. And there are multiple benefits of using policy as code. You can implement your security requirements with low friction, and there's no ambiguity onto what needs to be accomplished in order to meet those requirements. Your system would have security controls embedded in it from the beginning, which reduces the number of issues that need to be addressed once you're in a runtime production environment where they're harder to fix. And there's also increased visibility into the security controls your system needs to comply with, since we can store the applicable security requirements with our system's code, and we can easily identify what we're compliant with and any gaps that need to be addressed. So to implement policy as code, you need a declarative language that your policies are going to be written in. And one of the best tools out there to accomplish this is the Open Policy Agent project, OPA. OPA is an open source CNCF graduated project which its Rego language allowed us to have a unified language and a framework to do policy evaluations against our systems. And for a demo today, we're going to be looking at two example Rego policies, which come from the Kubernetes sys benchmark. The first example policy is to detect when the privilege escalation setting in the security context of a container is undefined or set to true. And here on the slide on the left side, you can see our two functions that help us check for that. On the first function on top, it will trigger when allow privilege escalation is set to true. And on the second function here, will detect when the setting is undefined. And here on the right-hand side, you can see an example of a YAML snippet that's not compliant with this policy. The second example, Rego, is checking when containers have the ability to run as root. So within the security context, we're checking whether run as non-root is set to false, or if run as user is set to 0, which is the root user, or if any of these are undefined. And here on the right side, again, you can see a couple of YAML snippets that are violating these policies. So the tool that we're demoing today is called Terascan, which is an open source tool that allows you to implement policy as code guardrails and includes many different Rego policies for security best practices on multiple infrastructure as code providers like Kubernetes, Helm, Customize, Terraform, and multiple cloud providers. And it's packaged as an executable, and that makes it easy for us to integrate it within your workflows in using the OPA Rego policies. For the policies it evaluates. So we're going to be integrating this into our CICD workflow. So this is a typical high-level picture of a GitOps CICD workflow where an engineer pushes code to a Git repository, and then this code goes through a CI process where it's built, tested, and we push a Docker image to an image repository. And then we're using Argo CD to sync with our Git repository and deploy our application into Kubernetes. So we can use Terascan here on multiple places. The first place will be on the engineer's local environment, where this is the best place to do IAC scanning, as the engineer can detect any issues as early as possible and fix them quickly without having to wait for CI jobs to execute or for the issue to become a bigger problem once it reaches the runtime environment if it's not detected early. The next place is part of your CI pipeline, where you can have a Terascan job execute and fail if there are any issues that you deem critical enough for your workflow, for your workload. Next place is using a pre-sync hook in Argo CD, where Terascan is executed and prevents Argo from syncing changes if there are any issues. And finally, we can use Terascan as an admission controller to your Kubernetes cluster. So when Terascan is running in server mode, it can be configured to be triggered by the Kubernetes admissions webhook and prevent issues from reaching your runtime environment. So you can check out the Terascan docs for example all of the different ways that Terascan can be used in your workflow. And today I wanted to demo how to use Terascan as an Argo CD pre-sync hook. So for our demo, we're going to be using the Argo CD example apps repository. In particular, I'm going to be using the guestbook app, the classic guestbook app, which is a simple Docker image that has a guestbook application. So I copied it over to my local environment, and I also am pushing the Terascan pre-sync. And here, what I'm doing is basically running a Argo CD pre-sync, which uses the Terascan latest Docker image, and we're running Terascan against my fork of the repository, in particular the guestbook application, and I'm only triggering this for high severity issues that Terascan is finding, and I'm using the default policies that come with Terascan. So the first thing I need to do here is deploy the application. See if I have this. Yep, so I'm going to go ahead and create the guestbook application. And now let's go to the UI. Now I see that guestbook here is appearing. I'm going to go ahead and sync it from the UI, which will pull the latest changes from the repository, and also will run the Terascan pre-sync as part of this. So we have to wait a little bit while Terascan runs on the repository as a pre-sync. So the way that Argo CD works with pre-syncs is that it will execute that pre-sync before it tries to copy over and deploy the application itself. So our sync has failed, and let's take a look at the logs. So taking a look at the logs, we can see that Terascan detected the two high severity issues that we discussed in the slides. It doesn't have any settings to minimize the admission of root containers, and it doesn't have anything regarding to the allow privilege escalation setting. So let me go ahead and add that to the code. So I'm going to add the security context for this container and set allow privilege escalation to false and run as non-root true, and give it a non-zero run as user. So now going back to this UI, I'm going to go ahead and sync again. And now Terascan is going to execute against our updated copy in our repository. So it should not find any issues. Great. So Terascan was successfully executed. If we look at the logs, we'll see that it didn't find any issues in our updated code, any high severity issues, because I'm filtering for high severity issues. And our guestbook app was successfully synced. So thank you for watching today. If you want to learn more about Terascan, please visit the GitHub repository where we have instructions on how to get started. Thanks for watching.